In this video, we are going to be doing the first part of 4.1. Chapter 4 is about linear functions, so this should all feel very familiar to you. Truthfully, I've not really understood why they put Chapter 4 here. We know so much about functions at this point. They could have even put this earlier, but let's take a look. Some formulas that you want to remember is the slope-intercept form of a line. So Rm stands for the slope. The b is our y-intercept, or the point 0b. Remember, slope you want to think of as a rate of change. So the slope-intercept form of a line is y equals mx plus b. Now, if we are given the slope and the y-intercept, we can use that form of a linear equation to just plug that information in, and we will have our equation of my line. So here they have told us that our slope is negative 1/3, and our y-intercept is negative 5. So if you just take y equals mx plus b, the equation of my line, you just plug in the m as your coefficient on your x, and you add or subtract your b. You're adding the b. If it's negative, it'll look like a subtraction. So that is something that should be very familiar to you. Now, slope can be referred to as a rate of change. And as you head toward possibly taking calculus, you want to think of that rate of change a mixture of ways. Sometimes you've seen it written as rise over run. This is the Greek letter delta that refers to a change in something. So delta y over delta x is the change in y over the change in x. And then we have our good old interpretation of the slope formula as y2 minus y1 over x2 minus x1. And the one that looks the most like an application for calculus would be the function at x2, which is y2, minus the function at x1, which is y1, over x2 minus x2 minus x1. So this formula and this formula are the same. In this formula, they use function notation to represent your y's, but the function notation f of x2 is y2, and f of x1 is y1. Another formula related to slopes and intercepts and points and anything like that on a line, this is a very useful formula. That is the point slope formula. So if I know a point x1, y1, and I know my slope m, I can use this formula to instantly find the equation of my line through that point with that slope. So if they want you to find the equation of the line passing through that those 2 points. So to find an equation of a line, this is my thought process. You need the slope, and then just use y minus y1 equals m times x minus x1. So that's the easiest way to find an equation of any line. Find the slope, then do your point slope formula. So yes, they gave us 2 points for question 2, but they did not tell us the slope. So my first calculation is to find my slope, which is y2 minus y1 over x2 minus x1, or any of the above types of representations. So that would be, if we label this x1, y1, and x2, y2, that would be 6 minus 4 over 5 minus 1 for a slope of 2/4. Now, 2/4 reduces down, so reduce that as much as you can. And now we are ready to use our point slope formula. So let me write that down. And let me remind you what we're plugging in. So we are plugging in the slope that we found, which is 1/2, in either of the points. I'm just going to use the 0.14, but it'll work similarly if you use 5, 6. So if we plug into that, it would be y minus 4 equals 1/2 times x minus 1. Now, depending on how Alex has you formulate your equation of the line, you may have to do a little rearranging. If you need to rearrange it, first thing you want to do is distribute your slope to both of the things in the parentheses, and then just add, in this case, add 4 to both sides. So 4 from 3/2, you can think of 4 as 8/2 minus 1/2. I'm sorry, 8/2 minus 1/2 is the same as 7/2. Now you can also write that as 3.5. That's acceptable as well. Just be careful. If it is a decimal that keeps on going or something like that, you should probably do leave it in fractional form. And I prefer the fractional form, but just watch how Alex asks the question. Now, if we apply that same thinking to problem or question 3, we need to find the slope. Bang, we got it. So if they've been kind enough to find the slope or give the slope to us, we can immediately move to step 2, which is use y minus y1 equals m times the quantity of x minus x1. So our point is -8, -4. That's our x1, y1. Our slope is -5/4. Let's put those into our equation. So my y1 was -4, so that's going to become a +4. Those will always change signs. Same thing for my x here. It was -8. If we're subtracting -8, I'm really adding 8. Now let's just distribute in that -5/4. Now to multiply -5/4 times 8, there's a mixture of ways to do it, but if you do -5 times 8, you get -40, and then divide that by 4, you get -10. That is one way to accomplish that. Now we just need to get it into, you'll notice here it says slope-intercept form. Now remember, slope-intercept form is that y equals. So we do want to solve that for y. And so if we subtract 4 from both sides, our final answer would be y equals -5/4 x minus 14. So that's a little bit about finding the equation of the line. So you need the slope, then just use the point slope formula. Some things to remember about linear systems or linear equations, that if the slopes match, your equations are parallel. So matching slopes, parallel. If your slopes are opposite signs and reciprocals, so if one is a over b, the other is -b over a, then your equations are perpendicular. So parallel, slopes are matching. Perpendicular, the slopes are opposite signs and also reciprocals. So let's look at an example here. It says, given the functions below, identify the functions whose graphs are parallel and perpendicular from the set. So what we're going to do is I am going to just, for each equation, I am going to pull out the slopes. So my first equation here is in y equals mx plus b form, and your slope is 2. G of x thinking the same sort of thing, the slope is 1/2. H of x, our slope is -2. And j of x, our slope is 2. So if we look at our slopes, these two slopes are the only ones that are perfect matches. So let's highlight those. So that means that f of x and j of x are parallel. Now they also have to have different intercepts for them to be parallel. Otherwise, they're just the same overlapping line. But let's take a look at, do we have any that are opposite signs? Well, the only one that is -2. And if you multiply that by 2, you get -4, or you can think these are not reciprocals. The reciprocal of -2 is -1/2, change the sign to +1/2. Oh, we got one like that. So a way to check is if you multiply two things that are opposite reciprocals, you should always get -1. So if we multiply -2 times 1/2, guess what? We get -1. So that's a quick little check to see if they are perpendicular, which they are. So g of x and h of x are perpendicular. You can even go back to your geometry roots there and use that little perpendicular symbol. So two lines are parallel if they have the same slope. Two lines are perpendicular if their slopes, when multiplied, give you -1, or you can think of them as opposite signs and also reciprocals. Or opposite reciprocals, I'll kind of say, which will kind of take care of both. Let's take a look at the last two, example 20 and example 21. Now, example 20 says, find the equation of a line that is perpendicular to 3x plus 3 and passes through 3, 0. Now, remember, the steps to find the equation of the line is you need the slope, and then you can use the point slope formula. Okay, so in a sly way, they've told us the slope. This slope is 3. Now I'm going to call my new equation g of x, just so I have another thing to, just a name for it. So I just picked that up. So if our slope of f is 3, if I want to be perpendicular to that, then my g function has to have a slope that is the opposite sign of that, so obviously negative, and also the reciprocal. So that when I multiply 3 times -1/3, I get -1. So now think about what our steps are to find an equation of any line we're looking for. Find the slope, bam, got it. Now we get to use the point slope formula. So our point is 3, 0. They'll give you a point most of the time. Our slope is -1/3. So let's plug that into our point slope formula. So we get y minus 0 equals -1/3 times x minus 3. Now, most of the time they will ask you to put your linear equation in slope-intercept form. That is our most common form to just be able to look at it and graph it very quickly. So what's great about this one is the 0 there. We don't have to move anything. We just have to distribute the -1/3 slope. So we get -1/3 x plus 1. And you can check any of these on Desmos. If you were to plug in y equals 3x plus 3, y equals -1/3 x plus 1, your second line should be perpendicular to your first line, and it should go through the point 3, 0. Okay. Now, if they would have mentioned the word parallel, we would have just got to use 3. We didn't have to flip it. But if they say parallel, use the slope that you're given. If they say perpendicular, you're going to flip it over. Okay. So let's read our last example. It says a line passes through the points -2, 6, and 4, 5. find an equation of a line that is perpendicular that passes through the point 4, 5. So first step, what slope are we going to use? Well, I don't know what slope I'm going to use until I know the slope of this. But if I just apply the slope formula, you make that x1, y1, and x2, y2, I get 5 minus 6 over 4 minus a negative 2 is 4 plus 2, which is negative 1/6. So the slope of the line that I am perpendicular to is negative 1/6. So my slope that I want has to be the flip of that, so 6 over 1, in the opposite sign. So instead of negative 6, positive 6. So the slope I'm going to use is 6. The point I'm going to go through is 4, 5. Remember your steps. Find the slope, use the point slope formula. So we're ready for the point slope formula. So if I plug into y minus y1 equals m times the quantity of x minus x1, I get y minus 5 equals 6 times the quantity of x minus 4. So just let's make that prettier. I'm going to distribute the 6 to both pieces and add 5. Okay, so again, you could graph the line going through your first 2 points, negative 2, 6, and 4, 5, and then graph the line y equals 6x minus 19, and they should be perpendicular, and then the final line should go through the point 4, 5. So if they use parallel, the word parallel, you get to just use the slope that they gave you. If they say perpendicular, find the slope of your original line and then flip it and change its sign, and you'll find the slope of what you want. And then every time, you know, in calculus, we find what's called the equation of a tangent line. Anytime you find an equation of a line, this is probably the quickest and most efficient formula. Y minus y1 equals m times the quantity of x minus x1. Know it, memorize it, it's not going anywhere. And then that leads us to our 4.1a homework. They're just the questions that you see here. Just follow the instructions. They should look very similar to what we just were doing. Okay, so there you go. Thanks.